this video, we're going to go over the installation, adjustments, and some basic troubleshooting for the Santon electric heater. First, locate an area to mount the heater. Mount it vertically on a flat surface, i.e. a board or wall, larger than the unit itself. Mount as close to the point of use as possible, but away from any potential splashing or leaking water. Next, you will need to connect the water lines. The plumbing connections are half-inch BPT accepting half-inch FIP fittings. Both the inlet and the outlet can be found on the bottom of the unit. The cold water inlet is on the right side. It should be preceded by a high-pressure discharge valve and a shutoff valve in that order. The hot water outlet is on the left side and runs to your hot water source. Never use PVC on the hot water outlet. Use instead CPVC or other heat-rated materials. Before moving on to the electrical connections, first purge all the air and pressure test the water line to check for any leaks and correct if necessary. Now, let's move on to the electrical connections. The power supply breaker is a 50 amp double pole, and the power wires and ground come into the unit from the lower right hand side of the back panel. Use 8 gauge for your ground wire, running it from the center space in the terminal block all the way to the ground bar of the breaker panel. Run one 8 gauge wire from each of the L1 and L2 connection points on the terminal block to the double pole 50 amp breaker at your panel. 8-2 wire may be used. Now turn on a faucet and double check for any leaking water. If found, then immediately shut off the incoming water and correct the issue. The unit is activated by water flow. You should see the plunger that is in line on the water inlet valve move up if you have proper pressure to the unit, which will engage your micro switches. Now, you may turn on the breaker to your heater. A red light should turn on indicating heating. The Santon has only one temperature setting, therefore the temperature is adjusted by water flow. More water or higher flow will give you less heat transfer per volume, resulting in a cooler overall water temp. In reverse, a slower flow or less water will result in a higher overall water temp. Please test the water to prevent scalds. Now let's expand on adjusting the flow of water and how it will affect the unit. In this frame you will see that we have several additional devices linked up to the water heater. These devices are to act as a visual aid illustrating how flow rate and incoming water temperature affect the outgoing water temperature of the unit. The device to the left of the unit has a flow meter that shows what our flow rate in gallons per minute, a pressure gauge that shows our pressure in PSI, and a temperature gauge that shows our incoming water temperature, which is around 60 degrees Fahrenheit for this video. The device that is mounted below the water heater is the temperature gauge showing the outgoing water temperature in degrees Fahrenheit. The first flow test that we are showing for this unit is with a 2 gallon per minute flow rate at 40 psi with an incoming water temperature of around 58 degrees. With these input parameters to the Santon, we are receiving an outgoing hot water temperature of around 88 degrees. In the second flow test, we are closing the valve on our hot water return side, which keeps pressure on the unit, but will decrease the flow rate. In this test, we are supplying 1.5 gallons per minute to the unit with around 60 psi and an incoming water temperature of around 58 degrees. With these inputs, our outgoing hot water temperature will raise to be about 100 degrees. So as we decrease our flow rate, we achieve a longer contact time with the heating element, thus giving us an increase in our outgoing water temperature. In our third flow rate test, we are reducing our flow rate even further, down to 1 gallon per minute, with our pressure increasing slightly to around 65 psi, and our incoming water temperature is still around 58 degrees. By reducing our flow rate down to 1 gallon per minute, we now have an outgoing water temperature of around 122 degrees. After the last test, we open our supply and turn valves for the unit all the way to apply max flow to the unit. You can clearly see how it has an effect on the outgoing water temperature. When you want to decrease your flow rate to the unit to increase your outgoing water temperature, please be sure to reduce the flow rate by closing the valve on the outgoing hot water side of the unit. In this clip, you can clearly see that if you close the input water valve to decrease your flow rate, you will also decrease the pressure on the unit, which may drop the pressure enough to cause the micro switches to disengage and thus shutting the unit down.